And if you're still working on your test, I'll make sure you guys get a copy of this, okay? Okay, 2, 11, 21. Okay, so objective. We're looking at max, min, story problems. Max, min, story problems. Sorry, that's kind of squished in there. Here. Story problems. Oh, I know. Every year I say I'm going to get... Right, Cameron? Every year I say I'm going to be a neater writer, and it never happens. Yeah. Never happens. After 35 years, I'm still not neat. Oh, well. It is. Okay, so take a look at this. So here's the thing. Here's an example. So you got a barn wall, and you want to build a fence. So you've got 60-meter fencing. You want to make a rectangle, okay? And you want to be able to make it as big as you can. So you could just go out there and throw together a fence, right? But this is Bill Davies, mathematician, farmer, right? This is Farmer Bill. So Farmer Bill wants to say, hey, I want to make the best fence I can possibly make and get the biggest area. So out of my 60 meters, I'm going to put some of it here and here. And that's a rectangle, right? Now, I don't know how much, so I'm going to say, I'm going to call this just X, okay? And this has to be X also, okay? I don't know how much I'm going to put. I know it's a rectangle, so I'll say so much here, okay? Now, hypothetically, if this is 20 and this is 20, then I'd have 60 minus 20, right? I'd have 20 left over. Or if this is 10, just think, if this is 10, 60 minus 20, I'd have 40, right? So hypothetically, I don't know what these are, but what's left over, the 60, is going to be 60 minus 2x for the length, right? So out of my fencing, I take so much here, and what's left over goes to the length. Does that make sense? It's a really important concept to get, okay? So what I put here and here, take out of my fencing, what's left over would go for the length, okay? Now, area, we want to maximize area, right? So I do know an area equation would be length times width, right? I know that. So I'm going to rewrite this as area, and I'm going to go area with respect to x is equal to length times width, right? So I'm going to go x times 60 minus 2x, okay? And then I just might multiply it through. Area with respect to x is equal to a 60x minus 2x squared. How am I doing? So far, so good? Stop me if you're confused, please. All right, so I've got the area, and now I want the largest. Well, one thing I could do is I could graph it and find the top, the vertex, right? But I also could probably do it without that. I know that I could use the negative b over 2a since it's a parabola. I can find the vertex with negative b over 2a. And so I would say, okay, well, that's a negative 60 over 2 times a negative 2. And I'm also going to show it on the calculator so you can see the graph, okay? Becomes 60 over 4, which is 15, right? All right, what does that tell me? Well, it tells me x is 15, right? So if x is 15, I'm going to go, okay, well, that means I can go back and take a look at my fence. And I can rewrite this as 15. This is 15. How do we do, Malachi?
Negative 60.
So then I'll have 6. Oh, go right here. So negative b.
I see what you're doing.
Right? Negative b over 2a, right?
So would it be 60 the x?
Not x. We only use the coefficients. Great question. Not the x. Just the coefficients. So if x is 15, then the length is 60 minus 2 times 15, right? Because x is 15. And so we wind up with an answer of 30. Okay, 60 minus 30 is 30. So here's my dimensions. My dimensions have to be, so I want a fence, so we're going to build it. So it's 15 by 30 meters. Is it meters? So that's the best fence, okay? So the question is, how big is that fence? Well, that's 450, right? So I can get 450 meters squared of area, okay? Now I can also show it on the calculator, and it's worth showing on the calculator. So I'm going to get my Desmos out. I'm going to show you what I do on the calculator so you guys can see it. Get my Desmos out. Whoops, not Spotify. Desmos. And so let me go ahead and type this one in, because I want you to see my original equation, this one here. So if I go my 60x subtract 2x squared, right? I don't see the darn thing because it's too big, right? So let me zoom it so you see it, okay? Right? Okay, and there it is, right? All right. What happens? This graph is kind of cool because x is the area. X is the width, and the y is the area, right? Okay, here we go. Area is y. So if I tap here, I get a point. X is the width, and the y is the area. So since I'm at the top, I've got the maximum area. Does that make sense? So my maximum area is 450, and that's with a width of 15. But what about all the rest of these points? Okay, for example, if I tap here, I don't know, tap anywhere. Tap, tap. Let's see if I get a point somewhere. Come on, give me a point. There you go. So all these other points. So all these other points, can you guys see that? All these other points are widths and area, right? So there's a width of 18 and an area of 430, okay? There's a width of 18 and an area of... Here's a... Come on, give it to me. Tap, tap, tap. Come on. Here's a width of almost 20 and an area of about 400, right? All right, so let's use our brains because we're smart. And I'm just going to draw this, okay? So we could build a fence. We could take this, and our fence could look like this. Like super long and super skinny, right? That's possible. That'd be a really dumb fence. But it would have really small width and really long. And that would represent something over here, okay, on the graph. Right? As I go further down, I've got a really short width, and I'm not going to get much area, right? Or I could have built my fence something like this, okay? So, right? I could have a really long width and short, right? And that would represent something over here, okay? So it shows all the possible, my calculator, the graph shows all the possible fences, all the possible widths. There's a width, hold on, come on. There's a width and an area, right? So by this, though, we can see that definitely, if we want the biggest fence, make this one, correct? Does that make sense? So let's go to the domain and range. Okay, so domain and range is not super hard if we figure out what the problem's talking about, okay? So domain is always all possible x values, okay? That's my domain, right? Well, in this problem, what does the domain represent? In this problem, what does the domain represent? Come on, you guys. In this problem, what does the domain represent? What does x represent in this problem? Represents the width, right? So in this problem, the domain represents the width. All right. So Farmer Bill is going to take Landon out here to help me build it. So camera's laughing. So what's the smallest width we could have in this fence? What's the smallest width we could have on this fence? Up to 0, right? We could have 1 inch. So we could say the smallest is going to be 0 is less than x. Now I'm not going to put the equal, because if it equals x, If it equals 0, I don't have a fence. Does that make sense? It could be 1 inch wide and super, super long. Okay? But it can't be equal to 0 because then we wouldn't have a fence. Okay? What is the widest this fence could be? What's the widest? Yeah, Malachi?
60.
Very close. We got to put very close. We got to put stuff. Yeah, Jack. 30 because we got to put some here and here. Do you see why it's got to be 30?
2 sides.
Because you got 2 sides, right? So it's going to be 30, 30, but not exactly 30 because we wouldn't have a fence, right? So the width would be less than 30. Nice job, Jack. So that's our domain. And then all the possible fences could be built, right? I mean, that would be a stupid fence. That would be a stupid fence, but we could build it, correct? So it's part of the domain because the domain says all possible fences. Now the range, of course, is all possible y values, right? But in this problem, our y value is our area, correct? So we're building a fence. What is the smallest area we could have? Yeah, Malachi?
1.
1, right? I'm going to say bigger than, we can even have 1 inch. I could have 1 centimeter. I could have 1 millimeter, but so I'm going to say less than, and we'll say A for area, okay? So just bigger than 1. I mean, that would be a really stupid fence. But we could build it, and what's the biggest area we could have? And we can actually put an equal to that, 450, right? That's exactly right. That's the biggest fence we can make. We can't make any more, okay? All right, that's not so bad, is it? So I don't have a lot of homework. We're going to do this in 2 days. Tomorrow we're going to do we're going to do cubes. So hang on to this, and tomorrow we'll do the second part to this, okay? So for today, just page 71, and we're going to do 1 through 4 all, and the extra is number 9. Okay? And we have time. I'll help you a little bit. Let me get this video loaded up first, okay? All right, stop recording. What'd you think?